row operations are something that you do to a matrix, but we can also write it as a matrix, and those are the elementary matrices. An elementary matrix will always have a determinant of 1 or -1. That's not really important here, but if you wanted to do the row operation, say multiply by 1/2, what you want to do is you want to do this row operation. You want to do this row operation, but you want to do it on an identity matrix. So if we do this operation on the identity matrix, we get 1/2, 0, 0, 1, because we multiply the first row of the identity matrix by 1/2. So this is our E. So your part A in this case would be 1/2, 0, 0, 1. And you can see if we multiply EA, we get 1/2 times 4, 0 times -4. So 2. 1/2 times 5 is 5 halves. 0 times 1 is 0. So just 5 halves plus 0. And then here, the second row of E just leaves the bottom row alone. 0 times 4 plus 1 times -4. So we have 4. And then 0 times 5 plus 1 times 1 is 1. So we can see how our result here after multiplying E and A is that the first row of A is multiplied by 1/2. All right. Now, if you wanted to, say, swap rows, let's say that we wanted to swap, let's call this E1 for now, E2. If we wanted to swap, say, first and third rows, first and second, I guess. We only have a 2x2 identity matrix. So if we're going to swap first and second row, all you do is swap them in the identity matrix. Normal identity matrix, I is equal to 1, 0, 0, 1. So if we swap the rows, we would get 0, 1, 1, 0. And if you multiply E2 by A, you'll see that the rows actually swap. Now here, this one's not really more complicated. It's the same process, but it's sometimes a little bit weirder. So in this one, if we wanted to say add, I'm not going to do the same number as part D. You'll have to figure that one out on your own. But if we wanted to say add 2 times row 1 with row 2. So we're taking row 1, multiplying by 2, and adding it to row 2. All right, that's what we're doing in the identity matrix as well, except we're not changing row 1. Row 1 is staying the same. So we have 1, 0 here. And then in the second row, we take 2 times the first row and add it to the second row. So 2 times 1 plus 0 is 2. 2 times 0 plus 1 is just 1. So this identity matrix, just to let you see here, if we do EA, we get 1, 0, 2, 1 times A, which is 4, 5, -4, 1. And if we multiply it straight across, if we multiply these two matrices, we get 1, 0 times 4, -4, which is just 4. 1, 0 times 5, 1, which is just 5. 2 times 4 plus 1 times -4. So 2 times 4 is 8, plus -4 is 4. 2 times 5 is 10, plus 1 is 11. Now again, this is not the answer to your question, because your question says 3 times row A, 3 times the first row of A and add it to the second row, right? Now this also extends to 3-dimensional matrices. So for whatever 3-dimensional matrix, if you wanted to swap rows, or if you wanted to add a row to another row, you just do that exact process to the identity matrix in dimension 3. So the 3x3 identity matrix. So again, if you wanted to swap rows 1 and 2, you just swap these two. If you want for your E, if you wanted to add one row to another row, you do that. You just add them together. Or if you wanted to multiply a row by a number and then add it, you multiply it and then add it, replace the row that you're adding into. And that should be enough to get you to what you need for this problem.